Right, the first thing you need to do with this is you need to balance the equation. So I have balanced it. If you don't know how to balance equations, you need to look back at that, because that's sort of grade 7, 8, 9 work. And then they say to you, how many moles of hydrogen, so I'm going to put number of moles of hydrogen as my question mark underneath the hydrogen, are required to react with, and I'm given a mass of iron oxide, and that mass is 50 grams. The minute I'm given a mass, I will try to find out the molar mass of the substance. And in this case, it's going to be 2 ions plus 3 oxygens. So it's 56 plus 56 plus 16 plus 16 plus 16, and that comes out to be 160. I then go number of moles is equal to mass over molar mass, and that is going to be equal to 50 divided by 160. And I get 0.31 moles. But that is the number of moles of iron oxide. The next thing that I need to do is I need to try and establish a relationship between the hydrogen and the iron oxide. So I'm going to say my relationship between iron oxide and hydrogen is 1:3. And I land up with, I don't have 1, I have 0.31, so I need to triple that number, and I get 0.93 or 94, because there's a rounding error in there, so it comes out to 0.94 moles, and that was the question mark. They didn't ask me to find the mass or the volume or anything. That was the question. Next one we've got is potassium chlorate. Again, you've got to balance it. What volume of oxygen? So the question mark is volume of oxygen. At STP, I immediately write down my molar volume as 22,4 moles, decimeters cubed per mole, but I'm not going to even pop the unit in there. And then I can say prepared from 10 grams. So I've been given a mass of potassium chlorate. So I'm going to work out the molar mass of potassium chlorate, and that is going to be 39 plus 35,5 plus 16 plus 16 plus 16. And I get 122,5. I can then work out number of moles as mass over molar mass, which is 10 divided by 122,5. And I get 0.082 moles. Now again, I need to establish this relationship between the two. So I'm going to say I'm relating KClO3 to O2, and the numbers in front are 2 and 3. But I don't have 2, I have 0.082, and that means that I need to divide it by 2 and times it by 3 and get 0.122. And I take that number of moles up to the oxygen. I want you to notice something. I did not use this 2 anywhere in determining my molar mass or anything. The only time I care about these balancing numbers is once I come along to working out the mole ratio between the two. And then only do I worry about the balancing numbers. Anyway, moving back on to the fact that I'm looking for a volume, and it's going to be number of moles times molar volume, so it's going to be 0.122 times by 22,4, and I land up with 2,74 decimeters cubed. Again, I need to balance this equation before I can do anything else, and the question mark is how many moles of oxygen, number of moles of oxygen that can be prepared from 50 grams, so I've got a mass of 50 grams of copper nitrate. I need to work out the molar mass of copper nitrate first. Again, I don't care about the balancing numbers. I am going to say that copper is 63,5 plus 2 times 14 plus 6 times 16. And that's going to come out to be 187,5. Number of moles is equal to mass over molar mass, which is 50 divided by 187,5. And I get 0.267 moles. Now I look at a relationship between the copper and the oxygen. So, sorry, not copper, copper nitrate and oxygen. And I land up with 2 is to 1. What did I do to the number 2 to make it the number 1? I divided it in half, so I have to do the same thing with this 0.267. I divide it in half and I get 0.13. The question mark only asks for moles. I don't have to do anything more with it. We've then got zinc and hydrochloric acid. Got to balance that equation before I do anything else. And then it asks me the mass of zinc needed. So I'm looking for a mass of zinc. When I'm looking for a mass, I need to find a molar mass, and the molar mass of zinc is 65,4. Needed to release enough hydrogen to fill, so I'm looking for a volume of hydrogen of 100 decimeters cubed. Luckily it is in decimeters cubed, I don't have to do a conversion, and so I am going to say molar volume is 22,4. I can work out my number of moles, volume over molar volume, 100 divided by 22,4, and I land up with 4,46 moles. Then I look at my relationship between zinc and hydrogen, and the good news is it's a 1-to-1 ratio. So whatever I have over there I can bring across straight away. Chunk. Number of moles is equal to 4,46. And therefore mass is equal to number of moles times molar mass, which is 4,46 multiplied by 65,4. And that is equal to, I have no doubt, 292 or something like that, and then it becomes 0,292 kilograms. Now we have this calcium carbonate. Luckily it's a balanced equation, but what's tricky is I've got 30 kilograms, which is 30,000 grams of calcium carbonate. That's my mass. And then I am working out what is the molar mass of calcium carbonate, and it's going to be 40 plus 12 plus 16 plus 16 plus 16, and that turns out to be 100. Number of moles is equal to mass over molar mass, which is going to be 30,000 divided by 100, and I land up with 300 moles. The question mark is what mass of this stuff, so I'm interested in the mass of slack lime that I'm going to prepare, and therefore I need the molar mass of that, which is going to be 40 plus 16, which is 56, and I go number of moles. What's the relationship? It's a 1-to-1 ratio, which is good news, so I can just bring those moles straight across, and I land up with 300 times 56, and then I need to divide by 1,000 in order to get 16,8 kilograms. Then it asks me what volume of carbon dioxide, so the question mark is volume, I need molar volume for that, it's at STP, can be given up by those 30 kilograms of calcium carbonate. Well, I know the number of moles from the last question was 300 moles. So I can now again just look at the mole ratio, which is 1-to-1, so I can bring those 300 moles across there. Volume is number of moles times molar volume, 300 times by 22,4, and I land up with 6,720 decimeters cubed, or you could have presented it in scientific notation. The next one, we are asked how many molecules. So again, I know my number of moles already is 300 moles, and I know that I've got a 1-to-1 ratio, so I can bring that across. And the question mark is number of particles. I know then that I can use Avogadro's number, which is 6,02 times 10 to the power of 23. I multiply that by 300 because number of particles is number of moles times Avogadro's number, and I get 1,81 times 10 to the power of 26 molecules of carbon dioxide. I'm given a certain mass of X, so mass is equal to 1,6 grams. I can't work out the molar mass because that's what I'm eventually going to have to work out, but let's see what happens. Reacts with dilute hydrochloric acid according to the following equation. If there are 896 centimeters cubed of hydrogen gas given off, so I am given a volume of 896 centimeters cubed, I need to convert that into decimeters cubed, and I do that by dividing by 1,000. And then I have got a molar volume, because it is at STP, of 22,4 decimeters cubed per mole. It's a long unit. Number of moles is equal to volume over molar volume, 0,896 divided by 22,4. And that comes out to be 0,04 moles. What's the relationship between hydrogen and X? Good news, it's a 1-to-1 ratio, so I can take that number of moles straight up there. And then I can say molar mass. Remember what my triangle looks like. Number of moles is mass over molar mass. So molar mass is equal to mass divided by number of moles, 1,6 divided by 0,04, and that turns out to be a neat 40 grams per mole.